Okay, so lesson 5.2 for Algebra 2 says that we're going to simplify square roots. We're going to solve quadratics by simplifying square roots. So we don't recall that a square root is a whole positive or negative number that when multiplied by itself produces another number. Example, the square root of 16 is 4 and negative 4. Because if I multiply 4 times 4, I get 16. And negative 4 times negative 4 gives me 16 also. This is called the radical sign. The number under the radical is called the radicand. So, radical sign with a radicand of 36. The square root of 36 is plus or minus 6. And here's how you can find the square root of 50. 50 is not a perfect square, but it has a perfect square as a factor. 2 times 25. 25 is a perfect square. If I split that 25 to its roots of 5 and 5, then the square root, that pair of 5s, one of them can come out. The 2 is alone, so it has to stay under that radical sign. 5 square roots of 2. Remember that any two radicals can be multiplied together. So the square root of AB is the square root of A times the square root of B. Square root of A times the square root of B. The radicands must be the same in order to add or subtract them. So, this example, x times the square root of A plus y times the square root of A, or minus, it could be either one, is x plus or minus y times the square root of A. If they're the same. An example problem with that would be, what if I had 2 square roots of 3 plus 5 square roots of 3? Same square root, the square root of 3. 2 plus 5 is 7 square roots of 3. So the square and the square root cancel each other out. So if I want the square root of A squared, then what I have is the square root of A times the square root of A, which cancels out that square root sign and just gives me A. Show you for example, what's the square root of 4 times the square root of 4? Well, the square root of 4 is equal to 2. Square root of 4 is equal to 2. So 2 times 2 is 4. That's how that works. So now, if we want to simplify this, I can't add and subtract things that aren't the same. They have to have this same radical attached. I can simplify this into 9 times 5. 9's a perfect square at 3 times 3. So that's 3 square roots of 5. 80 can be separated into 16 times 5. 16's a perfect square of 4 times 4. So that is 4 square roots of 5 minus the 2 square roots of 5 at the end. This can be done on any algebra calculator. 3 plus 4 is 7, minus 2 is 5. So 5 square roots of 5 would be the answer to that. In this case right here, that's a multiplication sign. So I just look at 2 times 4 is 8, and 35 times 7. Over here to the side, just quickly doing this, is 245. So I'd have the square root of 245. Now I can pull out some perfect squares there. And if I start breaking this down by fives, 5 will go into 245. How many times? 20, 49 times? Use a calculator. I'm doing that in my head, but you can use a calculator. Well, 49 is a perfect square of 7 times 7. So this is going to come out and multiply by that. 8 times 7 comes out of the radical. The radicand left underneath there is 5. So 8 times 7 is 56 times the square root of 5. And that's your final answer. Okay. Next page, 5.2, are the dividing radical rules. So when we talk about dividing two radicals, the word rationalize, the denominator, comes into play. Rationalizing the denominator is when you